Hi there, we're on section 5.4. This is permutations. So again, counting is hard, or it can be challenging. So question number 58, they call this a traveling fellow, the traveling man. A corporate sales executive has the choice of traveling to 4 of the following 6 countries. So there's China, Russia, Germany, Brazil, India, Nigeria. So there's 6 countries he could go to, and he's going to travel to 4 of them. How many different routes are possible? So in this case, a route would be, example, China, Germany, India, Nigeria. That's one possible route. Another possible route would be China, India, Germany, Nigeria. You'll notice that's a different route. If you were the travel agent and you were making a flight reservation, going from China to Germany to India is different than if you went from China to India to Germany. So these routes are separate routes, separate kind of traveling directions. So the first question when you're looking at problems like this is you have to ask yourself, is this a permutation or a combination? Permutation or combination? Combination. They're different formulas, so it's important to know which one you're dealing with. So for permutation, the big trick here, I look at the letter P and I think of a prize. P stands for prize. And in this case, a prize, the order matters. So the big trick about permutation is that order matters. It matters if you get picked first. If you get first place, that's different from getting third place. So in this case, because the order does matter, I'm saying that it matters if you go to China first or if you go to Germany first. It matters which one you go to first because you're trying to make the right flight reservations. So in this case, order does matter, so we're looking at a permutation, not a combination. Here's our urn. Sorry that my three-dimensional urns are so wonky. In this case, we have China, Russia, Germany, Brazil, India, and Nigeria. 6 different countries in this urn, and we're going to pull out for his travel route 4. Do you see that? He's traveling to 4. 4 countries. 1, 2, 3, 4. So we're picking 4. 1, 2, 3, 4. So I do this for me, for my own consistency. I have this urn. There's 6 things, and I'm pulling out 4, and order matters. So this is a permutation, so I put the P there. I have 6 things, and I'm picking, sometimes I say pick, or prize, 4. So now you can use your, there's a formula. I'm trying to see what page the formula's on. The formula is on page for permutations. Page 245. The actual formula, here it is N pick R. You kind of put the N there, little, and then a big P, and then a little r, is equal to N factorial, all divided by parentheses, N minus R factorial. And in this case, the exclamation point is factorial. It's part of the math, as one of my students said. I had a student who thought that this was me just being excited, N, but it's actually N factorial. So, using this formula, 6 pick 4. So we have 6 factorial, that's part of the math, divided by 6 minus 4 factorial. So this is equal to 6 factorial, all divided by 6 minus 4, 2 factorial. You can plug this into your calculator, or you can kind of do it the longhand. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial. 2 times 1. Factorials are nice because they kind of cancel. So then you have 6 times 5 times 4 times 3, and the answer was, I believe, 360. So how many possible routes are there? There's 360. How many different routes are possible? 360. You'll notice that this is it's not a probability, this is just how many different routes are possible. It's a number, just counting how many different routes, 360. So permutations, these problems involve how many prizes. Anything that's a prize is probably a permutation question. Things that involve giving out trophies. How many ways can the trophies be awarded? Things that involve routes. Like there's I think a newspaper boy problem. Some college students are delivering newspapers. The traveling salesman. So prizes, trophies, routes, things that involve order, where order matters. Order matters is a permutation. All right. Next up, combinations.